Okay, before moving on to the deformations part of the course, we need to tie up the last loose ends in our rig. So there is one thing that I want to show you that we solved using one approach before, and it was an easy solution, but it does have its drawbacks, and it has to do with the stability of the spine rig. So let me show you what kind of problems you could have with it and how we would go about solving them. So if you remember, we have in the let's first display our hidden objects. We were using this up vector object to help us stabilize the spine and also to rotate it around. So basically that's what we get. However, there is one problem with this, and it's related to how the spine is behaving. If we take, for example, this upper torso control, and let's say we want our character to arc back. So let's first rotate it, like so. And now let's move it all the way to the back, and you will see that at some point this happens. And you can see that the clavicles have flipped 180 degrees. And the reason behind that is because our joints here are using this guy as an up vector, but the joints on the top of the spine are now almost parallel to our up vector object. So the solution could be we can just grab it and move it over so that now all the joints can properly, let's say, see it. And then everything is working again. But of course, this means that the animator has to manage one additional object in the scene that he has to worry about. And then we would have to make this up vector something more of a control that he can grab and manipulate in the 3D scene. So that's not too bad. I mean, we could also we could always do that. But there is another way of doing this in a slightly more efficient way. So I'm going to show you what that is. Let's go to our spine torso section. And let's find where this guy is. Here it is. And here we have our curve. So what we're going to do is, instead of using one up vector for all the joints, because as you can see, the further up the hierarchy we go, the more we have an angle over here, is we're going to create a separate system that will have one up vector per joint. Okay, and we're going to create it in the same way that the spine is made up, which is we're going to use a curve with up vectors on it, and then that curve is going to be deformed by the same objects that we were using to deform the spine curve. So let's do that. Let's create a new mesh item. It's right here, and we're going to call this one curve center spine up vectors. Okay, and right now this mesh item is completely empty. So what we're going to do is go to our spine IK curve, and let's go into polygon component mode, and I'm just going to drag over here, and it's selected in there. So I'm gonna copy, and I'm gonna come to my new mesh item, and I'm gonna paste. Okay, now that is pasted, I'm going to move it forward. All right, like so, right there to the front of the character. Now let's go back to item mode. So what I'm gonna do now is create a bunch of locators that I'm going to constrain to this curve over here. And I could actually use this guy, the spine joints up vector, but I'd rather just use new locators and constrain them, and then change all my constraint up vectors to those locators than having this guy affect everything when I move it. So let's create a new locator. And this new locator, we're going to bring it in to our spine IK rig group. And let's call him constrained center spine up vector 0, 1. And I am going to shift select my new curve. And let's go to modifiers and say path. Okay, so there he is, constrained to the start of the curve. And let's make him a lot smaller. And actually, because this guy is an up vector, I'm going to give him a different shape. I'm going to turn these guys into little pyramids. There you go, not solid. And let's make them smaller and make them face the Y direction. Okay, so there he is. The next thing we're going to do is duplicate him and create several more of these. And we're going to use the same spacing that the joints have. So if we want one of these locators per joint, that's going to be 1, 2, 3, 4, 5, 6 probably. Let's see how many joints we have. We need 1, 2, 3, 4, 5, 6. This is the last one that has a path constraint. So let's grab our spine up vector and let's duplicate him. 2, 3, 4, 5. 1, 2, 3, 4, 5. One more, 6. I'm gonna have to change the numbering because Modo added just the numbers using his own numbering system. And to make things easier to manage, I'm going to make them into a hierarchy. That's not really necessary. It's just for me to make this a little bit more manageable. It doesn't really matter anyway, because these guys are going to be all constrained to the curve. And actually, you know what? I'm not going to do that. I'm just going to parent them directly to the curve itself. We'll see if that doesn't give us any problems. I don't think so. And when I did this, Modo completely changed the ordering. So let's just reorder this a little bit better. And this guy on top. There you go. And let's give them their corresponding values. So let's see what those are. So let's go check the path constraints. So this guy is at 0%. The next one is 16.67, but because of all the rigging that we have going on here, we're probably going to be better off bringing our constraints into the rig over here and wiring everything properly so that we have the up vectors also affected by the scale of the character and all the other behaviors we've already done. So let's select everything here and add them, and here they are. So let's move things over a little bit better. Let's see, this is the first one. Then we have this guy, he is the 6th one. Let's move him under. So this is for the second one. Then we have for the third one. Then for the fourth one. The 5th up vector and the last one. And we need to add the channels to these nodes. So you remember we were using the offset channel. So let's use those again on these guys. So let's add the offset channel. There we are. And let's move them to their corresponding positions. So here's the first one. Looks like we have a 7th locator over here. So let's duplicate this guy once more. And this is going to be 7th. Let's move him up. There we go. So this is our 7th locator. Let's move it there. And let's fit these guys in between. Oh. Like so. We're going to put them a little bit behind so we can recognize them. And then this guy should be here. This guy should be here. Actually, I'm just gonna drag and drop them very quickly. There we go. There you go. So something like that. Okay. And now all we have to do is right now all of our locators are at the same position at 0% because they also duplicated their constraints. And let's just wire up the values that we're using here over to the offset channels. And I'm gonna be collapsing these at the same time. So this guy would be over here. Looks like we're getting zeros. Oh, of course. I'm taking the wrong nodes. I'm taking the ones that were used for the roll values. So let's do that again. So our offset values are coming from the expressions. So let's take this expression, wire it there. Let's keep an eye over here. And this one is done. Let's take the second one and this output, wire it to this offset, and now it's right there. Okay, let's take the third one and wire the output over to that offset. And we have that one over there. Now let's take this output onto the next offset, and there we have another one. Then this guy. The sixth one. And lastly, this last one. Oops. This guy doesn't have the channel yet. Let's add it. There you go. Looks like I did a funny connection there, accidentally. Okay, we're done over here. Let's see what that looks like. So as you can see, we have a curve with these guys on it, but right now they're not doing anything. So the next thing we need to do is to have our curve behave exactly the same way that the other curve is behaving. And that we're going to do by basically adding the points of this curve to the weight containers used on the other curves. So let's go find our weight containers. So we have here lower spine and upper spine. And we're going to do the same thing. We're going to select our curve, go into vertex component mode. Let's select all the vertices on the curve, and with the lower spine container selected, let's go to the formers and set add points. Now the points on this curve were added to the container, and let's see what weights we get. Right now everything is 100%, so we're gonna have to also reweight these guys. We'll do that in a second. Let's now control select the upper spine and control select the lower spine to deselect it, and also say add points. Now these points are part of the two containers, so this means that we're going to be using the same influences that we are already using to deform the spine curve to deform this one. And you can actually see what that's going to look like by, let's rotate this guy. Okay, so you can see it's working. It's curving the curve that we have for our locators over there for the up vectors. It's not doing it exactly the same way because we have not worked on the weighting, but for this curve it's not as critical. All we want to have is locators that are basically there moving along with the spine. Okay, now you will see that these guys are flipping and rotating a lot. That's not really a problem because these guys are only going to be used as up vectors, but if you want to somehow mitigate that a little bit, what you can do is let's see if we can improve that just by changing the up vector for the path constraint on these guys. So let's use the z-axis instead. Let's see how that behaves. That's much better. There's no more flipping on those guys. But as I said, if ever it comes back because the character is rotated in a funny way, then it's not a problem. Now all we need to do is to take the path constraints on the joints and reassign the up vector instead of using this locator we originally used to use these guys. Okay, so let's just do that. So we're going to go to our first joint and let's select the path constraint. Okay, and let's select our locator here at the bottom of the curve. Let's go to modifiers, and well, we cannot assign the up vector at this point because we first have to unassign it from this locator over here. So we're gonna select both the constraint and this guy, hit the shift key and say remove up vector. And now that we did that, let's deselect the locator, select the first one here at the bottom and say assign up vector, and that's going to be the new up vector for the constraint here at the bottom. So let's repeat that with every joint we have. So let's select the second path constraint, select the up vector, remove it, and then select our second locator on the curve and assign it as an up vector. So this guy is now pointing this way. Let's continue doing that for the other path constraints. Now this guy with this guy, remove. Oops. There you go. And now let's select the third one, assign the as the up vector. Let's go to the fourth. And now select our fourth locator on the curve. Let's go to our fifth. Assign as the up vector. We only have two more to go. 1/6. Assign, and the last one. There you go. So now all these joints are using these new locators as an up vector. So what that does is, if we test our spine again, let's rotate it and let's move it backwards. You can see I can really push this and we get no flipping. And that's because the up vectors are actually always very close to the axis of each joint that is being used to, well, as the up vector basically. So this is a much more stable solution, and it doesn't require any animator intervention. So there you have it. That's all we wanted to do. So all we need to do is check a few more things in the next videos, and we're gonna make sure this guy is as solid as possible before moving on to working on the deformations. Okay, so catch you up in the next video. Okay, there's a few things we still need to do to fine-tune the behavior of the spine, and let's start with one of them. If I take, for example, the lower torso control and I rotate it, you will notice a couple of things. First, our curve here, it's taking the shape of a straight line from top to bottom as I rotate either end of the torso. And the reason for this is that all the weights on the vertices that this curve has right now are at 100%. So we have 100% on each vert for both weight containers. Since both weight containers are part of this normalized folder right here, well, at least the transforms that are using those weight containers to create their effect, then this results in a totally even weight of 50-50% for each influence on either side of the curve. And this gives us this straight line. So what we're going to do is we're going to change the weighting on the influences that the weight containers have for each vertex so that they resemble more closely the weights that we had for the main curve on the spine. And if you remember correctly, we had set those weights to go from 100% down to 0% as you went down the curve or up the curve, depending on which container we were weighting. So we're going to use exactly the same weights for this curve. So let's do that. Let's go and find our curve right there. And let's also expand our weight containers. And with the curve selected, I'm going to start with the upper spine container. So we're just going to control select it and go into vertex component mode. And let's select, say, the first vertex on the curve. If I go to adjust weights, I'll see that it has 100% weight, which is what I want. So this guy's fine. Let's select the next vert, which is this one right here. And now I can see that this also has 100% weight, but that's not the weight value we want. We actually want this vertex to have 83% weight. So let's bring this down to 83. There you go. And you will start to see immediately some movement on your curve. Well, at least because I post my control down here to influence the curve. It's already rotated, so let's go to the next vertex. And this guy needs to be 67%. There you go. And then the next one needs to be 50. And then the next one needs to be 33%. This one right here needs to be 17. And the last one will have 0% weight. Okay, so you will see that already the shape of the curve has changed a bit. So let's do the same, but not for the other container, the lower spine container. And I can see that it has 100% for this vertex, which is fine. Let's go to the next one. So this guy needs to be 83%. The next one needs to be 67. This one right here will be 50%. Then this guy needs to be 33. This one right here needs to be 17. And the last one will be 0. There you go. So now we have a totally different curve right here. As you can see, it eases in and it eases out. And the nice thing about it too is that since we're using the same weight containers as for the main spine curve, then this also works with the fall-offs that we have been using for our system. So I can change the ease setting on the curve, and as you can see, that's going to give us some different shapes right there. So this is pretty much it. That's the first step towards fixing a little bit some of the character's torso. Let's see what this does. As you can see, we have a curve that resembles a lot more what you have in the actual spine of the character. It's not as linear anymore, which is a lot better. And it's working nicely. So the next thing to do would be to check what do we do about the upper torso rotation that happens when I rotate the lower torso. As you can see, the shoulders are turning, and that's something that we should probably try to minimize as much as possible because the animator might be using this control to pose just the lower part of the torso, and he would not want the upper part to be disturbed. So let's take a look at that in the next video. Alright, let's take a look now at what we're going to do about our spine movement. And the problem we have right now is that as we rotate this guy around its y-axis, you can see the shoulders moving, and we would like to prevent that from happening. So there's quite a few reasons why this is happening right now. One of them is we're using these up vectors to determine the direction each joint is facing towards. And the other one is the way the setup was rigged before, which is using all the joints on the chain up to the neck. So we're going to modify that a little bit. But one thing I will want to do is, because this control is directly affecting the way our up vectors move in space, because the joints that are driving the weight container deformations are related to these control objects, we're going to require a different control to be able to control the upwards rotation on the spine. So I'm going to create a new locator, and I'm going to parent it to our existing control. So let's just say parent with no compensation. It's going to move right there up to the same location. And let's go and find it, and let's call this one control. And actually both are gonna not be controls anymore, but you'll see that in a second. Center spine twist. Okay, so, and I'm gonna make him smaller for now. That's it. So what I want to do is to use this guy to control the rotation, because that way I'm going to be able to drive the entire spine without having to worry about the position of the up vectors. If we take a look at how we had rigged this, you'll notice that what was going on is we have our hips control, which is the existing control, and this hips control is influencing the way the roll channels are getting calculated, because we have this little math rig going on over here, and it's being fed partly by this control. The other part is from the shoulders. So this, all of this is getting added up and going into the roll value of each constraint. So I'm not going to use this control anymore. I'm going to use the new one I created, but let's make up some space by moving these guys up here. And let's get our spine twist control and its Y rotation channel. Let's just select the Y channel and add that. Let's bring it here. Okay, so what I'm going to do is take all these connections and shift move them over to this new channel. So what that did is the following. Let's go back here. You will notice that as I rotate on Y, this guy, the spine is still rotating. And that's because the up vectors are following that rotation, as you can see. That's why we get a lot of rotation down here and less rotation as we move up. So, but we still see some rotation, and that's because the up vectors are definitely moving. If I take my new control, you'll see that we also get rotations, but these ones are strictly driven by the rig that we have that is driving the roll value on each joint. So that's great, because now I have isolated that effect and I can better control it. In order to stop the rotations from propagating up to the shoulders, all I have to do is make sure that this joint is not rotating from the values coming from this control I just created. So if we go to our schematic view, I'm going to make this a little bit smaller, we'll find that that's this spine joint right here driven by this constraint. Okay? So all I have to do is find which node is using the Y channel coming from this spine twist, which is this one right here, and I'm just going to disconnect it. Okay, so what that's going to do is, as I rotate on Y, this guy, you can see there's no more rotations on that joint, and therefore the shoulders stay in position. There's still rotations upwards though, and that's because the joints after that one are still wired. So all I have to do to prevent that is go up to the next constraint, which is this one right here, and find the same connection. I know that it's already on the lower multiply node and it's the connection on the bottom, but I can just check that it's actually going to the spine twist joint control, sorry. Disconnect that and do the same for the last one, which I suspect is this, and that's correct, and disconnect that one. So now when I rotate my new control, I get no rotation on the upper joints. I only get rotation on this part of the spine, and it's still weighted, so I get more rotation at the bottom than I do at the top. Okay, so we've been able to isolate this. The problem I have is I still can go back here and rotate that, and I'll get back into trouble. So I definitely don't want users to be able to do that. Okay, I want them to use this control instead to control the roll of the spine. So how are we going to do that? Well, it's actually pretty simple. I'm going to demote, in a manner of speech, these two objects, and they're not going to be controls anymore. I'm going to drive them both from a third control. So the way I'm going to do that is I'm going to create another locator, and I'm going to match it to this guy. Okay, and I'm going to drag and drop it into the same group, which is the spine controls group locator. And let's rename this guy to it's going to be control hips. So let's rename first our current control, and we're going to call him just locator. This is going to be our locator hips, and this guy is going to be the control hips. Okay, same for this guy. It's not a control anymore. He's going to be a locator. Okay, there we go. And this guy's going to drive these two guys. So let's go back to the schematic view. How is he going to do that? Well, it's pretty simple. We're going to take our new control, bring it over here, and add its position and rotation channels to the schematic view. And we're going to take our locator hips object, and we're going to bring its position channels, well, and the rotation channels too, to the schematic. We're just going to get rid of the Y channel, which is this one right here. And we're going to wire things in the following way. We're going to take the position channels of the new control. Let's make sure everything is zeroed out before I do so. Perfect. We don't want to run into any problems. And wire those onto the position channel of my previous hips control. And we're going to wire the X and Z channels over to this guy, and the Y channel over to our new locator. Okay, so what that does is that I can take this new hips control and I can move it around, and it's going to behave just like the previous one. And when it comes to rotations, I can rotate it this way, and it's going to rotate our previous control. And I can rotate it front and back. Okay, but when I rotate it on Y, it's going to rotate our spine twist control. Okay, and I can have this rotated on another pose, and because I'm still because the spine twist joint is locator is a child of the hips, it's going to be oriented with the hips control. There's one thing though that you might have noticed right now. Our order of rotations is wrong, because when I rotate my new control on the x-axis, the y-axis stays put. And we definitely don't want that. We want the y-axis to also rotate with the control. So we need to determine what's going to be the proper order of rotations for this guy. So because the y-axis is probably the most important part of this setup for the spine twist setup, we're going to use that as our first axis in the rotation order. So let's try, for example, YXZ. And when I rotate on Z-axis, everything moves. Oops. When I rotate on the X-axis, everything moves fine, except the Z-axis is now stayed put. But that's okay. I can still get a decent pose out of that, and more importantly, I can get the proper rotations happening on the twist of my spine. So I think this is a nice order of rotations to use. You can also experiment with YZX, in which case when you move the Z-axis, the X-axis is not going to follow, which I actually don't like that much. I think I prefer the other one, because that way I can pose my spine, and going back and and front, and have the x-axis follow. I mean side by side, sorry, which is probably what you'll do most with your character. So let's use the previous one. And that's pretty much it. All that's left is give these guys some more accurate visual cues into what function they perform. So what I'm going to do is I'm going to take our new controls hips and I'm going to shape it just like our friend here. And I'm going to give him the same wireframe color. So let's do that. Let's go to him. Let's go to Locator Shapes Custom. It's going to be a box, not solid. Let's shape him a little bit better. Like so. And it's going to be smaller on the y-axis. And we're going to move it down. I guess that's pretty close. I don't have to be too crazy about it. And now let's give it the same wireframe color. So if we look at our previous one, those values 7441. There you go. Oops. Is this 0.01? What was that? Oh, 1. There you go. And now we can take the previous locator and we can just remove the draw options and give him his default shape. Okay, let's just make him smaller. And we're going to do the same for the spine twist. And in this case, this guy, I'm going to have him a little circle shape on the y-axis just to know that it's part of the, that is, its function is just twisting the spine, and that's it. And we're done. That's all we needed to do. We can test our rig again. It appears to be working just fine. And of course, the shoulders are not disturbed. Of course, you have here another thing, which is that the shoulders also rotate all the way down to the spine. Although it's not that much. But if you want to tweak that, you would like the shoulders to limit the rotation further up the region of the torso, you can follow the exact same procedure, which would be to create another 2 locators and modify the rotations and wire everything the way we just did for the lower torso, so that we have a new setup for the upper torso. For now, we're going to leave it just right there and keep moving on with the rest of the rig.